Hey y'all, it's Stephanie Ringgold here. Today we're going to discuss solving equations that involve rational expressions. And just as it sounds, they are equations where you have one or more terms in the equation that's a rational expression. And rational expressions are fractions. And so when we jump right into this, when we get into solving equations that have rational expressions, you need to first identify what the domain is, or more importantly, what restrictions you have on your domain. And so looking at number 2 here, and each one of these fractions has a variable in the denominator. And so we have a possibility of getting a 0 in our denominator. So we can't divide by 0. That's a big no-no. And so we need to look at what value of n is going to put a 0 in our denominator. And so looking at this, if n was 0, we would have a 0 in our denominator. So we identify from the get-go that we have a restriction. Regardless of what we solve this down to, n cannot be 0. So we've got that established right now, and then we can move into solving this equation. And so to solve an equation that has rational expressions in it, rational terms, we need to multiply everything by the least common denominator. And so looking at n squared, n, and 2n squared, our least common denominator is 2n squared. And that's what I'm going to multiply every single one of these terms by. I'll move my n can't be 0. And so I'm going to multiply 2n squared times 1 over n squared. And what that looks like is 2n squared times 1 over n squared. Now, if you want to, you can write the 2n squared as a fraction. You can just put it over 1 if you need to see it as a rational expression also. Bring down that plus, and then I have 2n squared times 1 over n equals 2n squared times 1 over 2n. All right, so now when we simplify each one of these expressions, I cancel what's common on the top and the bottom. And so when I have 2n squared times 1 over n squared, I've got the n squared is the same on the top and the bottom. And the result of this multiplication, when I multiply numerator times numerator, denominator times denominator, I wind up with 2 times 1, which is 2. My next set of multiplication, 2n squared times 1 over n. Well, one of those n's cancels. And so this multiplication, when I multiply numerator times numerator and denominator times denominator, I'm left with 2n to the first power times 1, which is just 2n. And then this last one, 2n squared times 1 over 2n squared, well, the whole 2n squared cancels, and I'm left with 1 times 1, which is 1. Now I have an equation with no fractions that I can solve. I want to get n by itself. And so I've got to isolate any term that has an n in it. I need to get all that over on one side. So I'm going to move this 2 over here with the 1. And the way I get it across the equal sign is I've got to do the opposite operation. So right now, 2 is positive, and I undo a positive with a negative. So I'm going to subtract 2 from both sides. And then going over here, I wind up with 2n equals negative 1. Now I'm at the point I've got 2 times n equals negative 1. So I need to undo that multiplication. And the way I'm going to do that is with division. So my 2's cancel over here, and I'm left with n equals -1/2. And I know that that's an okay answer because at the beginning I said n can't be 0. And what this is saying is that n can be anything as long as it's not 0. So we're good here. In this one, n equals -1/2. Now I'm going to move down here to number 8. It's good practice that when you have binomials or larger polynomials in the denominator, go ahead and just rewrite this factor. Factor everything you possibly can. So m squared minus m, I want to factor that. That's going to be m times 1 minus, I'm sorry, m minus 1. Then I'll look at this 1 over m. Well, I can't factor that, so I'm just going to bring it down. And then this last one, I can factor that denominator the same way I factored the first one, as m times m minus 1. Now that I've got that factored, I should be able to look at this and identify that m cannot be 0 or 1. And I got that from setting the denominator equal to 0 and solving for m. I do have a video on solving equations, so you might want to go look at that if you need some help, but I'm not going to go through that in this video. Okay, so now we've identified what m cannot be. Now I need to look at what is my least common denominator. I've got an m, I've got an m minus 1, I got that m again, I've got that m again, and I've got m minus 1 again. So my least common denominator is m times m minus 1. And that's what I'm going to multiply every single thing by. So when I take that m times m minus 1 and I multiply it by this fraction down here, what I've got is m minus 1 all over 1 times 1 over m minus 1 plus, take that, multiply it times over here. So I've got m minus 1 times 1 over m equals, take it and multiply it by this fraction, m minus 1 over 1 times 5 over m minus 1. Now, the idea here is I want to eliminate my fractions, so I got to go cancel everything that's common on the top and the bottom. So I've got m's are common, and I've got the whole m minus 1 is common. So my result here is 1 times 1, which is 1. Then I'll look here at the next one I want to multiply. I've got m's are common on the top and the bottom, and I'm left with m minus 1 times 1 equals. The last one, I've got m common on top and the bottom, and I've got m minus 1 common on the top and the bottom, and I'm left with 1 times 5. Now I want to solve this. I don't have any more fractions. In order to solve, I need to combine like terms. Well, looking at this, I've got 1 minus 1 is 0, so those go away. And my result at this point is m equals 5. Not a whole lot of work to do with that one once we got it all multiplied out. And so m equals 5, and I'll look back at what I know m can't be. So chances are I'm pretty good. But let's say I want to make sure. I want to be certain that I did get the right answer. We do have a way to check. We're going to go back wherever we have an m, and we're going to plug that 5 in. So looking at this, 1 over 25 minus 5 is 20, plus 1 over 5. Is this going to give us the same thing as 5 over 25 minus 5, which is 20? When we add fractions, we got to make sure we have common denominators, and my least common denominator is 20. So I got something over 20 plus something over 20. Is this going to give me my 5 over 20? When I went from 20 to 20, nothing changed, so my numerator's not going to change. When I went from 5 to 20, I multiplied times 4. I multiplied that 5 times 4 to get down here to the 20. That means I need to multiply my numerator times 4. So now when I do this addition, I just add my numerators. 1 plus 4 over 20 is in fact 5 over 20. So I know without a doubt that my solution is 5 for M. Okay, I'm going to do one more example, and then you can practice these all you want. I do have the CUDA software worksheets. They do have the answers on the last 2 pages so that you can work this and know if you got it right or wrong. So let's move on to number 16. Actually, I want to do one a little more interesting. Let's do number 14. So looking at 14, I do have an equation because I've got my equal sign. I have an equation that involves rational expressions. Not every term is a rational expression, but we can write it as a fraction if we need to see it that way. Now, when we rewrite this, because I have a denominator that I can factor, when I rewrite this, I have 1 over 1 equals 1 over x times x plus 2 plus x minus 1 over x. And so looking at this, I know that x cannot be 0 or negative 2. And at the same time, I can identify that my least common denominator is x times x plus 2. And that's what I'm going to multiply every single one of these terms by. So when I take this whole thing and I multiply it times 1 over 1, I multiply it times 1. That's nothing more than x times x plus 2 equals multiplying x times x plus 2 over 1 times 1 over x times x plus 2 plus multiplying this one times that last term. I've got x times x plus 2 over 1 times x minus 1 over x. And then looking at this, I'm going to cancel what's common on the top and the bottom. X's are common. X plus 2 is common. Looking at this third one, I'm going to do my canceling before I move down to the next line. All I have that's common are the x's. So now I wind up with x times x plus 2 equals 1. That's what this is. This is just turns into 1. And then this third one is x plus 2 times x minus 1. Okay. So now I've eliminated all my fractions, and now I need to solve for x. In order to solve for x, I've got to get rid of my parentheses. And so right here on the left side, I need to distribute that x inside the parentheses. So I've got x times x is x squared. X times 2 is 2x. Bring my 1 down. And now I need to FOIL this out. And the way I do that, I've got x times x is x squared. X times -1 is negative x. 2 times x is 2x. And then 2 times -1 is -2. And at this point, I need to simplify everything on the left side, everything on the right side. Now, left side, I can't combine those. I can't simplify, so I'm just going to bring it down. But on the right side, when I combine my like terms, at the same time, I'm going to write everything in highest power order. So I'm going to lead off with my x squared. So I'm done. Oops, I didn't mean to get rid of it like that. So I'm done messing with x squared. Then I look at negative x plus 2x turns into positive 1x. So I'm done with those. Now I've got 1 minus 2, which is -1. Now, when we solve equations, a lot of times it's really good practice just to go ahead and make your equation equal to 0. So we're going to move every single thing over here. We're going to move it across the equal sign. And the way I do that is I do the opposite operation. So right now I've got positive x squared, so I'm going to minus x squared. What I do to one side, I'm going to do to the other. I've got a positive x here, I'm going to minus x. I got a -1, I'm going to add 1, and I'm just going to put it over here because I don't have anything to line it up with. And so over here on the right side, every single one of these goes to 0. But over on the left, I've got x squared minus x squared. Well, that went away. But I've got 2x minus x is 1x. And then I've got my plus 1 that just gets to tag along. Now, getting x by itself, I'm going to move that 1 back over here because I realized I didn't need it over there. And so we wind up with x equals -1. So yay, I've finished. I've solved for x. I'm excited, but don't forget, go back and check your restrictions. Is your answer okay? And in this case, I said x can't be 0 or -2. X equals 1. So chances are I'm good to go. I hope this video helped. Please let me know if you have any questions.